Welcome to Math 1324. In this section, section 4.2, we're going to link together system of equations with something new that's called a matrix. So if you look there on the top, I've got this system of equations. 2x plus 3y equals 5, x minus 2y equals minus 1. Now, we want to see a new way to represent and solve this. The square brackets that you see here is called a matrix. Where the equals is, I've got this vertical line. The numbers on the right are here in the right side of the matrix. And in here, I just grab all of the coefficients. So a 2, a plus 3, a 1, a minus 2. So the number with its sign. Now, looking at a matrix, matrices have rows. So here's row 1, row 2, row 3. And it's often abbreviated with the capital R, 1, 2, 3, or however many rows that we've got. We also have columns. Here's column 1, column 2, column 3. And we say that the size of the matrix is the number of rows by, this is not multiplication, stands for by how many columns. So this particular matrix would be 3 rows and 3 columns. This matrix would be 2 rows and 3 columns. If I look down the main diagonal of the matrix, well, like here, 1 and 2, this is called the main diagonal, going from the top left to the bottom right. Now, typically, we only talk about the main diagonal if the matrix is square. Now, what do I mean by square? Well, the matrix is 2 by 2, 3 by 3, 10 by 10. It has the same number of rows and columns. Now, looking at all these numbers, we need a way to represent where is it? And we use the notation Aij. The first number is the row it's in. The second number is the column it's in. So for example, the 3, where is it? Well, it's in row 1, column 1. That's why it's A13. A23, let's see, second row, third column. Yes, that is a 0. What about this 2? Where is that 2? Let's see. It's in the third row, yeah, and it's in the second column. So this would be A32. Notice that's different than if it says 2, 3. So the order you see these makes a difference. First is the row, the second is the column. All right, in question 1, they say, well, what is the size of this matrix that we're looking at? Well, let's see. It's got 1 row, just 1, and then looking down, 1, 2, 3 columns, and so it is 1 by 3. If I flipped it around and wrote 3 by 1, it would look like this. 1, 2, 3 rows, but just 1 column. Let's see, in question 2 here, they want to know, is this matrix square, column, or row? All right, well, let's see. Looking at it, it's got 2 rows and 3 columns, so it's 2 by 3. It's of no special type because square means the same number. Column is exactly like you think it should be, and that is, it's just a column of numbers. And row is just one row. And again, square is the same size. But this one is just no special type. It is simply 2 by 3. What about this guy? Well, again, 2 rows, 3 columns. In question 4, they want me to find the principal or main diagonal. All right, well, that just comes from the top left down to the bottom right. And so I see A11 is -5, A22 is -4, and A33 is 5. All right, in question 5, they say, see if you can figure out where A13 is. Okay, well, let's see. A1 is in first row, and A13, that's the third column, and that's a 1. And they also wanted A11, well, first row, first column, and so that's an 8. All right, so what about the 4? 4 here is in the second row, second column. All right, what else? Let's see. In question 6, they want me to take the system and write it as a matrix. All right, well, let's see. The coefficient matrix is just the coefficient of numbers. And the augmented matrix has the vertical line in it, and it includes the numbers on the right-hand side. All right, in question 7, they want me to learn to do some row operations. This little symbol here that looks like a two-headed arrow means we can swap 2 rows. Okay, so right now here's row 1, here's row 2, right? So I just want to swap them out. So row 1 is now going to become row 2, and row 2 is going to become row 1. All right. Question 8. Here they want me to take -2, multiply it by row 1, and the little arrow means replace the old one with the new version. All right, so here's row 1. I've got -2 times row 1, so I simply multiply every number by -2. And then whatever I get, which was -2, 6, -4, it becomes my new row 1. All right, what does 9 mean? Let's see. It says take row 1, add it to row 2, and then the line, the little arrow here, make a new row 1. All right, so here's row 1, here's row 2. Add them up. 7 -16 -11. And it's going to become my new row 1. Nothing happens to row 2. See, I just carried it over. The thing on the end here is the only row that will be new. All right, question 10. They want me to take -5 times row 2, all right, add it to row 1, and make a new row 1. All right, well, let's see. Here's row 2, so -5 times each one of those numbers. All right, I'm going to add that to row 1. Here's row 1. Add them up. I get a -19, a 27, and a 42. That is my new row 1, so I just copy it down in the matrix. There is no change to row 2. All right, in question 11, we finally begin to see what all these row operations, what they're for, why we even care. So we take our system of equations, we form the augmented matrix, and now I want to work on this matrix using the row operations. And what I want to transform it into is something that looks like a 1 on the top left. I'd like to get that first. I want to get a 0 under it. Second. Then I want to get this 1/3, and finally I want to get a 0 above it last. And if I can make my matrix look like this, the answer for x1 and x2 will simply appear in these positions. The other thing that's important is we usually want to use 1s to make 0s. To make 1s, we multiply or divide by something. So looking at this matrix, I want a 1 in the top left. I see one right there. So I'm just going to swap rows 1 and 2. All right. Then I want to use that 1 to make a 0. Ignore all of that stuff. That stuff is not important. What is important is simply the 1 and that 3. So I'm thinking I'll take -3 times that 1, because then -3 plus 3 would make a 0. But if I multiply by something, I have to do it by the entire row. All right, so let's see. I'm going to take row 1 and multiply all the way through by -3. I'm going to add that to row 2. All right, so I get a 0, a 4, and a 16. And that's where I'm taking that item and placing it in right there as my new row 2. So look, I've got a 1, got a 0. I now need a 1. And if you remember, I said we make 1s by dividing or multiplying. So I'm going to take row 2 here and divide by 2. And then I'm going to fill that in. All right, at that point, let's see, I've got a 1, a 0, a 1. I want to use that 1 to make the thing above it 0. But I don't have to do anything here because when I just add them up, I get 0. All right, so add them up and I get my new row 1. And I'm simply going to plug it in. So the good news, I got 1s on the main diagonal, 0s everywhere else, and so my answer just appears there. x1 is 1 and x2 is 4. Row operations. All right, question 12 says solve it again. Okay, so let's take a look here. So I took my system of equations. So here's my system. I wrote down the matrix. There it is. All right, so there's no easy way to make a 1. All right, so, but I'm thinking, I see this -8. I see that 16, and I'm thinking 2 times -8 is 16. And so I can add these two up and make a 0. All right, so I think I'll do that. So I'm going to multiply that second row by 2, add them up, and I'm going to make a new row 2. And look, I have a whole row of zeros. In the previous case, we were able to get an answer. In this case, I get a whole row of zeros. And if I get a whole row of zeros, that means I have an infinite number of solutions. Or if I graphed these two lines, it would tell me that they are the same line and they are touching at every spot. So I want a formula that I can generate all of the answers. So since row 2 is all zeros, I'm going to let x2, my second variable, be t. And then I'm going to plug that into the top equation. So 16x1 plus 4t is equal to 4. I'm going to move the 4t to the right. And then I'm going to divide everything by 16. And so what I get is x1 is minus 1/4 t plus 1/4. And remember, x2 was t. So my formula that will generate all of these infinite number of points looks like the x1 part and the x2 part. So you pick a t that you like, 2, 10, minus 50. You could figure out what the first part is, and you could also generate all of the solutions. All right, what about this one? Let's see. I'm going to again make my matrix. Don't have any ones, but I do see I got a 3 and a minus 9. So here I am going to multiply through by 3, add it to row 2, and when I do that, notice I get 0, 0, 22. So again, I've got 0, 0, like we did previously. And in the case above that, remember, we did have ones and we had an answer. If we have 0, 0, a whole row of zeros, but the number on the right-hand side is not 0, see, here it is 0. If it's something other than 0, that means these two lines, or whatever objects we have, never intersect, and therefore there is no solution. So to wrap it up, if I have ones on the main diagonal, and I will get my answer on the right. That means the two objects intersect in one point. If I get a whole row of zeros, that means I've got the same lines. They are sitting on top of each other. There are an infinite number of solutions, and I need to get a formula for them. And if I get 0, 0, and something not 0, that means our problem has no solution. And that concludes this particular section.